This is a maximizing revenue quadratic problem. And I'm going to write down my data as I read it. Theater tickets are sold to students for $20 each. And when I sell my theater tickets for $20, 300 students will buy them. Now, if I increase my price by $5, 30 students fewer will buy them. So I need to figure out what is going to be, well, first I need to have a quadratic equation that models the revenue, but I'm looking to see how am I going to maximize my revenue here? What price will get me the maximum revenue? Well, revenue is a concept you have to become familiar with because you'll see a lot of problems with it. And revenue is the price I charge times the number of tickets I sell. That equals revenue. So for example, if I was selling tickets at $10 each, and I sold 2 tickets, I would have revenue of $20. 10 times 20. That makes sense. So in this case, I'm starting out with a ticket price of $20, but I know that I might raise it by $5 any number of times. That's what my x is. My x is the number of times I might raise my price by $5. And every time I raise my price by $5, the 300 students that I start out with reduces by 30. There's that x again. That's the number of times I raise my price. That's going to give me my revenue. And I see that this is going to be a quadratic equation. So the equation is going to be, my first is 6,000, 20 times 300, plus my outer, well, it's a negative number. My outer is a minus, so it will be minus 600x plus 1,500x minus 150x squared. That is what my revenue is equal to. Let's simplify it a little bit. That's 6,000 plus 900x minus 150x squared equals r. And let's put it in standard form. Negative 150x squared plus 900x plus 6,000 is equal to r. And that kind of makes me happy because since my a is negative 150, I know I'm going to have a parabola that opens down, which is going to give me a vertex that will be a maximum. And that's what I'm looking here to do, is to maximize my revenue. Now remember that x represents the number of times that I change my ticket price. And looking at this equation here in standard form, I could see that my y-intercept is going to be 6,000. So if I was to graph this, I'm just going to do this here real quickly. If I was to graph this, I know I'm going to have my x is number of times I increase the price. And my y is my revenue. That's my r. See, right here, that's my y. So I know I'm going to have a parabola, and I know it's going to cross the y-axis at 6,000. So it's telling me if I do not increase the price any number of times at all, I leave the price as it is, I should have a revenue of $6,000, which when I go back to my original problem, makes total sense. Because at $20 a ticket, I sell tickets to 300 students, and that is $6,000 of revenue. So I'm kind of confirming as I go along that I'm on the right track with this problem. So I have the quadratic equation in standard form. I've rewritten it right here. And I need to find out what selling price will produce the maximum revenue for the theater. Well, the maximum right here, whatever it is, the maximum revenue, is going to be my vertex, and that will happen right along the axis of symmetry. Okay, so let's figure out my axis of symmetry. Negative b divided by 2a. Negative 900 divided by 2 times negative 150. Negative 900 divided by negative 300, that's equal to 3. That 3 is my x value. And that x value, remember, is the number of times I'm increasing the price. So I'm increasing the price 3 times. Well, if I'm increasing the price 3 times, and each time I'm increasing it by $5, that means I'm increasing my price by $15. $15 is the increase plus the original $20 that I was charging, means that my selling price that will maximize my revenue is $35. And I could also find that by going back up to here and realizing that my price is represented by 200 plus 5x. Well, 20 plus 5x. So 20 plus 5 times x, which is 3, well, that again is equal to $35. So that is the price that is going to maximize my revenue. Finally, what will that revenue be? Well, I need to find what is the y value, let's put a color here, the y value here that's going to give me my revenue when x is equal to 3. So I'm just going to plug it into my equation. I can do it any number of ways, but I don't know. I think I would probably do it using this form of the equation. I already know that when I have x equals to 3, this is 35 times 300 minus, well, that would be minus 90. So I have 35 times 210 is equal to 7,350. That is the maximum revenue that I would have if I raise my ticket price 3 times. Let's just graph that on the calculator so that we can just see what it looks like. So I'm going to graph my equation. I may as well just graph it in standard form. I have negative, use the negative sign, negative 150x squared plus 900x plus 6,000. And I'm going to graph it. I'm going to go zoom 6. But I can tell you right now, and you're probably clear too, well, it shows up a little bit there, but it doesn't look very accurate because I know for a fact that my y-intercept is 6,000. So I need to get my y values like way, way up there. I need to get them way, way up there. So I'm going to change my window. And I'm going to make my y maximum, well, I'm going to make it 7,500. I'm going to make it 7,500 because I already know that my maximum revenue is 7,350. So if I make it 7,500, I should get up there. And I'm going to change my y scale. Usually what I do is scale, and that's just the tick marks on the axis. But I make them about 1/10 of what the difference is between the minimum and the maximum. So I'm going to make my y scale in terms of 750 units. In fact, I'm not even going to do 750. I'm going to make it in terms of thousands because those are even easier to figure out. And as far as my x's, well, I know I'm going to leave it negative 10, a positive 10, and I'm going to press graph and see what it looks like. And there's a nice parabola. And it's showing me what my revenue is. So if I wanted to find the maximum, I'm going to go second, calc. I'm going to find the maximum. Now I already know that according to my calculations it was 3, and it looks as if in my graph that it's about 3 as well. But I'll set my left bound over here at, say, 1, and I'll set my right bound over here at 5. No, I don't want to make a guess, but I can again see that my maximum point on my parabola is there between my left and right bounds. I will press enter, and it tells me my maximum is where x equals 3, and then it gives me the correct value for y. So I've confirmed on my calculator that, that I got this problem correct doing it by hand.